So in last class, we saw basics of Pig, some basic commands of Pig. So in this class, what I will do is I will refresh all the basic commands that we have done in last class. And in addition to that, we will do some little bit more Pig programming. We will also see how we can do Pig macros. So are you guys seeing my screen? Can you guys see my screen?
Yes.
Okay.
Yes, Shiva.
Okay, so what I will do is I'll scoop some data uh, from MySQL and then let's work on that data. Actually, I think I scooped some data already. Okay, what I did is I scooped this data from MySQL. I scooped first name, last name, department, and number. So let's take this data and do all the Pig programming on this data. This data has only 4 columns: first name, last name, number, and department. So we'll see all basic commands on this data, and we will also see some joins and macros on this data also. So I will go ahead and I'll show you where I scoop this data. So this has 4 part files and each part file has 250 records. So we will use this data in Pig. So let me log in into Pig first. I'm logging into Grunt shell. In here you can use all general Unix commands like clear. You can use cd, you can use ls, you can use pwd, you can use anything in here. So in cd, when you do, let me do it again. I'm doing cd, it will tell you. I'm doing pwd, it will tell you where you are at right now. It's showing me that I'm in HDFS user Cloudera. So I'll clear it and I will see. Let's go to our scoop job. So here I'm going to use a Shiva Pig. In there I will go into scoop data. In there I will go into I'm using this data, and you can access all Hadoop HDFS commands with normal Unix command when you are in grunt shell. Like if you are outside grunt shell, to access this file, we should use Hadoop fs-ls, right? But in grunt shell, we can use only like cd, ls, and general Unix commands to access even the Hadoop data. So internally, this grunt shell will be converting into this Hadoop commands. So I'm logging into cd all files. So right now I am in this file 1. So I want to see some data in this. Let's see the data. Cat part m. See, I can see the data. It's first name, last name, this is number, and this is department. So I can use all commands, Unix commands on Grunt CLI. Let's go and jump into this some basic queries. So I will load some data. User Shiva scoop data all files 1. I'm going to use, when I scoop the data into Hadoop, by default I got comma delimited. So for pig we should say that this file is comma delimited, and so for that we use something called pig storage, so that pig can understand that the file is in comma delimited format, and in that pig storage we will specify that it is a comma delimited, and we have to specify the column names. So what columns we have? The first column is first name, last name, number, and department. Okay, so I'll show you something in here. We know that there are only 4 columns in here, right? So we are specifying first name, last name, number, and department, but we are not specifying any data types. So if we don't specify any data type, by default pig will assume everything as byte array, and when it actually runs the code, when it actually takes the data, then at that time it will internally cast into the data type that it sees on the file. So pig is smart enough to internally cast into the to its own data types. But the downside it is there will be a casting that will happen, which might degrade the performance. So if we know for sure what data types we are using, it's good to put the data types in here. But before that, let's make sure that pig is using what. Let's see what data types the pig has came up with. So I'm doing describe A. So describe A will show us that this relation A has 4 columns: first name, last name, number, and department. And by default, pig is using byte array. So as I mentioned earlier, it's good to have it's good to specify data types. So I'll go ahead and specify data types. First name char array, last name char array, number and char array. So now after specifying the data types, I see first name as char array, last name as char array, number as in department and grade. So I specified all these data types. So it will see, it will use this data types. So let's clear it. Now relation A is done. So we loaded A like this, and now let's do simple statements like we will limit A with 10, and then as I told you earlier, dump A will print the records to the screen, output records. I'm just dumping the records. I should have shown you the describe. So it's a good it's good to do describe for every relation when you're learning, because you can easily see what data types the pig is using. So unable to open iterator for alias. So let's see this. A load. So describe A. Okay, so describe A, and then what I will do is I'll do P equal to limit A 10. Then also I'll do describe B. I'll get same. Fail to read data from all files 1. Use data. It's not able to read the data from that location. Let's see that. Data is available. Okay, thing going on. Splits execution failed. Load using big storage. First name, last name, number, and department. Open iterator file areas. A. Okay, now it's reading. So I'm just using a load using pig storage, and then I did dump a. So let's do describe a one more time. So all byte arrays, and then limit a to 10. Then if you describe b, B will also have the same schema because all you're doing is using a limit. It's still going to use the same schema but limit to 10 records. So let's dump B and see the output. So we should get 10 records when this gets completed. So 75% complete. Then we will do for each statement, and then instead of dump we will use store. So now I got the data, so it's giving me only 10 records. So this we will get it by using limit statement. So now I will use, you can use multiple relations. So even after dumping, grunt CLI saves the previous relationships, so that you can keep on running the next relations by using the previous relations. Like here, I'm going to use for each A, that means for each record in A relationship, I want to generate first name dot last name. So I'll use for each relation in A, I only want 2 columns. I'm selecting generate is nothing but for each record just show me 2 columns. So when I do describe on C, I'll see only 2 columns. The schema is only 2 columns. And then I'll use store command to store this data into some location. Test file. So as I said, dump and store both will run the map reduce job. Dump will show it on the screen. Store will save the data into some HDFS location. So until now we saw load, limit for each, generate, and store. Then we will see some order by, then group by, and then some joins, and then we will go into the some little bit complex statements like joining multiple tables all together. So its store is completed, so we can go to that location to see if it got loaded. User Shiva. So it loaded the data. So you can see cat so it stored the data. It's showing only first name dot last name. So then we will do let's do some order by. So I will load data again. We know that A relation has first name, last name, number, and department. Let me do that again. So just to be clear. Okay. I have A first name, last name, number, and department. Okay. And then I will do is I'll do order. I'll create new relation, which is D. I can if I use the same name, it overwrites the existing relationship in this cell. So previously I used a B relation. Now I'm using it again, so that means it overwrites the previous relationship. So I'm doing B. I'll say order A by first name, last name. So now dump B. sorry, what did I use? So I'll say B order A by first name, because I have first name, last name, number and department. All I will say is I'm going to order A by first name and department will be in ascending. So when I see describe B, it will still have the same, because it's going to pull the same records, but these records will be in ordered fashion by first name and department. So let's say dump A. Let me limit the records. See, actually let's just go ahead and dump record to see if it ordered or not. Dump B. %, complete. You can also see the job status in here, in this location. 75% complete. So now it's, what I did is I did order by first name and then department. So it did first name and then department. So this worked fine. So let's go ahead and do some more. Let's do group by. So we have A, and then let's do group by department. So all we will do is we'll say group A by department. So once you do that, I'll show you what happens. If you want to see describe B, so this is what happens when you do group by. The schema will be in this way. It will create a bag. B colon is nothing but it's a bag. In this bag, when you say group by department, means it will first take the column which you are grouping by, which is nothing but the relation in here, which is nothing but this A, and then it puts everything in this bag, which are the collection of tuples. So for each department, it will create a tuple and have a complete set. Let's run this to get a bit more clear picture. So it's completed now. So I'll show you what it exactly did. So we did group by department. So if you see this, see this becomes one bag. In here, let's take an example. So research and development is one department. So we're grouping by department. So it will take research and development in here. It will show the first. Okay, research and development, and then in that bag it will put all the tuples in here, which is a collection of all individual records, columns. So everything in here, like all 4 columns, all author, 6, and research and development. So after grouping like this, if you let's say if you're doing count or sum, it will take this bag and individually count the records. So if you say, let's say after grouping, if you want to do a count on first name, so this first name, it will count how many names, like 1, 2, 3, and it will give the total counts, and same way it does the sum of values. So this is how a group by happens. It creates a bag, and each bag will have a tuple for each record. So let's go ahead and do count also. Let's see if it works. So we saw B is group A by department. Then to count all the first names, so what we will do is C for each B, I'm going to generate nothing but a group, which is nothing but with this group in here. We are saying that for each B, generate group. Group in here is nothing but our department. And then I'm doing a count of. So now if you see, I'll show you something. If you see describe B, this is a group. But if you see describe, this is actual first relation. So in third relation, what I'm trying to do is I'm trying to get the column for the first count of first name. So what I have to do is I have to take the group from here. So in each group, I need to specify on what column you have to do action on, like either sum of first name, count of first name, or sum of last name. But that column, first name column, is not available here because as you see, this is bag. Bag is unordered list of tuples. So this is not a schema. This is, you cannot actually specify this as first name. Instead of that, you need to specify that first name from relation A. I'll show you how to do it. So now I am saying for C, for each B, generate group, which is nothing but department from B. And I want to do count of. Now you have to specify count from A, not from B as count. I'll show you what happens if you try to specify from B. So I said B. So we are saying, see, we get an error. It says that unexpected symbol or at or near group, because it doesn't know that first name exists in B. B is a bag. It doesn't have the actual first name value. So that's why we have to specify A. So oh, sorry. Okay, it's done. So let's see. Describe C. See, now if you see describe C, in this you will have only two values. One is department and another is count of total values, because that's what you're doing. So what this will try to do now is for each B, that means for each B is nothing but in this example, for each research, and let's take an example of research and development. So for each research and development, okay, so from here, for each research of development, it's trying to do count of first name. So it will take this whole bag, and we said group. When I say for each C, generate group, nothing but this department, I want to have a count of first name. So we are telling take it as first name and it will count it. So it will, in this bag, it will count, it will go to each tuple and count the number of first names. So let's dump C. So now you see that we got department and the count of first name. So we got total counts in each department. So that's how you do group wise. Let's go ahead and do a simple join. So I'll take relation A, but in this relation A, I'll just, actually what I'll do is, I'll take this relation A. In this relation, I have 4 columns, right? So 4 columns, right? So what I will do is, I'll take this relation and I'll create another relation only with 2 columns. So for each A, generate first name and then department, right? Then I'll do describe B, and I will do the same thing, but I will select, now I will select another relation. Instead of first name, I'll select last name. So now if I do describe C, so now I have 2 relations. In first relation, I have first name and department. In the second relation, I have last name and department. So what I'm trying to do now is to join these two relations and then get the output. So let's use join function. D relation, I'll say join, then A. Here this relation name can be anything. You can, instead of A, B, C, you can put the relation which is more understandable. Like you can say join department, or you can say load underscore statement. So I'm just using A, B, C, D. So D is equal to join A by department, and then I say same thing, not A, sorry, B by department, and then I'll also say C by department. So I'm specifying in D relation, I'm asking join B and C by department. So now if I do describe D, I get, since I joined B and C, I get all the columns from B and all the columns from C. So like this, from B, I'm getting first name and department, and from C also I'm getting last name and department. So let's go ahead and dump this A. Sorry, dump B. So what I got here is by joining those two tables. So first name department, last name department. So I joined all the two tables, and I got the complete record. So this is how we do join. So now I'll show you some more. Let's do everything together now. Some more big statements. So what I will do is I'll take this. Let's go to cd user Shiva scoop data. Cd all files one cat So what I will do is let's do some more statements where we want to see only the departments that has maximum number. So I want to see the records that have like maximum number for in each department is 10. So I want to see only the records that has maximum number as 10, but I want to group it by department. So each department, whichever has, I need to pick each first group by department, and then get the maximum number, and then get the complete record. So for example, like if it pulls public relations, it pulls public relations 10 and this complete record. If it pulls human resources, it pulls this records. sales marketing this record. So it can be one value, or if it has multiple values, it will pull multiple values for the same department. So let's go ahead and do that. So I'll use the same load statement. So using the same load statement, after load statement, I'm going to do for each A, generate first name, last name, number, and department. So I'm pulling all the records, and then C, first I need to read that maximum number for every department. First I need to group it by department, and group for that I'm using relation B, group B by department. So after this, let's go ahead and do describe for each relation. So B will give first name, last name, number, and department. So that's that. So after grouping, we have to get max of number. So for that we use for each C, generate group, which is nothing but department. Then I say max of, I have to use actually this. Let's do describe C. Let's do describe A. Describe B. Describe C. So now I have group, and the actual value is in B. So for that, I need DD for each C, generate group as department, and then max of B dot number as max number. So what I did is I'm taking every record from C, in fact read each tuple, group as department. I'm reading for every group, I'm getting a max of that number, max of which is number is in B dot number as max number. So now if I do describe B, it will have all four values. For each generate group as department and then max as number. So when I do describe D, it will have two values. One is department and we have max number. So now what I will do is, now I have to get complete records. So I have a department, I have a max number. So I just need to join it. So I'm join D by, I need to join both on department and maximum number. So department, joining on department and max number, joining D to, I have to join it to B to get the actual complete record. B by, same thing, over there we have a department, comma, number. Here you're joining with max number with numbers, so that you will get only those records. So when I see describe E now, it will pull four columns. We have max number, first name, last name, and the number and the department. So we got four columns. So now let's generate final output. F is equal to, for each key generate, I want to generate department, then first name, last name, then number. I think we'll get an error. So let's go ahead and see that. Okay. So projected field does not exist. Describe DE. Okay, so we have to specify because department is, we have to alias it. So let's do this. D colon.
Last name.
Describe E. So in E we have everything. So since I haven't done the aliasing, if I have done the alias with different name, I shouldn't have specified the relation, but I was using the same alias as the department. So in E, if you see, I got department from first table and department from second table. So we need to alias and specifically say which relation we want to pull the same name. So that's what I did for F. For each E, I'm generating department. In here, we just need to mention I'm pulling it from D, relation D. First name, last name, and number. Now, if you describe here, you will have department, first name, last name, and number. So now let's go ahead and dump F. Now I should get only records grouped by department and which have maximum number. So maximum number for each department is 10. So I need to get number 10 records for every group. Only number 10 records for each group. So after this, okay, so it pulled only records number 10 records for every department. So you see in here for research and development, it pulled records, and for sales and marketing, it pulled 10 records. So this is for joins. So I'll show how to do macro, and then I'll wrap up today's class. So until now we saw. So this is what we have done. We have done A relation loading data, B relation I'm just pulling the records which is needed, C relation I'm grouping by department, and D relation I'm just from each group I'm just selecting the max number, and E relation I'm joining it max number with the actual record to get the only records that have maximum number as 10, and then I'm dumping it. So what if in our requirement, if we have to reuse this always group by department and generating the max number? What if in requirement we will have multiple scenarios where you have to group by department and reuse and generate the max number? So if we want to reuse, we don't want to write these relations all the time. For that kind of scenario, there's something called macros in Pig, which is a reusable packages. So we'll take the same example and put these two statements in macro and then run it. So using macro, the advantage is you can use that same macro in any Pig statements by just defining macro once but reusable many times. So let's go ahead and see that. So for that we need to define macro. So I'm defining macro as count underscore group, and what is the input for macro? I'm going to pass this b as an input to macro. So this is b is an input to the macro, and I need, after passing the input, I need to get output as department output as group comma count, which is nothing but this one, group comma max of, actually let's do count. So if I pass this as the input, I need to get this as an output, right? So that's what I'm going to do. This is going to be input, this relation b is going to be my input, and then on which key are we going to group by? So we have to pass this, since we are going to use this relation and also this relation in macro, we have to specify we are doing these are nothing but passing parameters to macro. So b comma, I'll say group of group key is passing a parameter, and then after grouping, on what value you are doing count, we are doing count on this first name. So you have to pass another parameter for first name. So I'm just going to pass, you can pass any name in here, because when you pass as a parameter, you are going to pass it from the actual script that we get as an input. So this returns y, and then here you write actual code for that macro. What I am doing is I'm taking the input, which is nothing but $b as input, and then I'm grouping $b relation by, you have to say dollar because you're passing parameter, it has to accept parameter like this, and then we are grouping by dollar group key. This is done, and then now you have to return output. So whenever you return output, then you have to specify as $y, because you're returning it as a parameter to the output. For that output, what you're doing is for each a, you want to generate group, same like earlier, you want to generate group, and let's go ahead and do count. Let's do count of nothing but what value are you trying to do count on. So in this relation, which is nothing but $b relation, I'm going to count on name. This might be a little confusing, but it's not so hard to. Okay, I'm creating a macro. In macro, I'm accepting a relation b, and I'm passing a group key on what group key you are passing, and what is the count that you want to get on what column. And then in that you do actual relations. You see group on this relation by department. Is this nothing but this? You're exactly doing this. Group B by department, but you have to pass it as a parameter. And here You're doing exactly like this in relation. So you're doing for each A, which is nothing but here, generate group and then do count of B relation dot name nothing but here we are using name and then doing count of this one. So now it's done. Now let's see how you can use macros in your code. I'm going to load same thing user Shiva, same file, big scoop data, all files one using storage as last name, number and department. Now it's done. First name, last name, number and department, all files one. Describe A is done. Now B is nothing but for each A it generates first name, last name, department. That's done. Now I'm going to use macro in here. C is nothing but I'm using macro which name is count of group, which is what I have used here. Count of group, and then the input values I have to pass is B, and then I have to pass, you can use instead of B you can use any value X, Y or anything, but you have to make sure you use the same parameter in here. So I'm passing B relation and I'm also passing the group key which is department, and then I'm passing I want this as a count. So I'm passing B, department and first name. Now let's do describe C. So now I'm doing a count. For each A, I'm just getting group and count. So I'm using describe C. Let's see dump C will actually give output or not. Let's run that. Okay, it's actually doing any group by. Let's see what it did. So $y for each A generate group count of B dot name and return Y. Let's see this. Let's define that macro again. So once I ran that macro statements and then ran the code, I got the count of for each step. I have a count now. So for each department, I did a group count of first names. So I got this output. So I can show you. Let's paste that code again. So this is what we did. We did define group, passing relation, passing group, and passing name, and we're returning some another relation. So in this relation, we are grouping by relation by group key, and then for each group key, we are generating count of name. So for each department, we are getting to count of names. So once that is done, we are loading relation A, and then for each statement, we are trying to get first name, last name, and number and department, and passing that relation to this group. We're passing relation, department, and first name, and then did a dump of C. From there, we got this output. So with this, we're done with today's class.